Let's take a look at lesson 5.3, bell ringer. It says simplify the following. And I want to put up here our acronym. Spot oil. There we go. All right, really quickly to make sure we remember the S. Gabriel, S. What does that S stand for in spot oil? Simplify, that's correct. And with simplify, you're really looking for two things. You're looking for one, can I cancel opposites? And if you don't see an opposite, you look for, do I have a greatest common factor? Meaning something shared that I can factor out. Here, do you see any opposites? A tangent multiplying and dividing, or do I see a GCF, something shared between two separate terms? I don't. Do you see anything shared? Nope. Okay, move on. P, what does P stand for? Give you a hint, P, what? Pythagorean. You look for ones and squares. Do you see any ones or squares? No. So then you move to O, which is opposite denominator. Now we do have a denominator, but specifically it's a conjugate you need to have, which means something like 1 plus CSC theta or 1 minus CSC theta, something like that. I don't have opposites here, so I'm not going to do that on this problem. So what I am going to do is the T. What does T stand for? Transform. We're going to transform everything to sines or cosines. So here's, I know on your desk right now, you do not have an updated formula chart. So let me clear this ink, sorry. What I'm going to do is I want you to look on my page for a moment. That's too big. Okay, go to the trigonometric functions and identities side if you're looking on your formula chart. And what you'll notice is yours that's on your desk is a little bit different than mine, is they did do an update here this school year, 2021, 2022. They've updated this. However, there's still a typo on it, so I want to fix that real quick. Here's how you transform. You use, oops, I didn't mean to circle Pythagorean, sorry. I meant to box up reciprocal and quotient. These are what you use to transform sines and cosines. Here's the error though. This has cotangent twice. This should say tangent here. And tangent is for a reciprocal equal to 1 divided by cotangent. That's one error. The other one is on your formula charts that are on your desk. So that part is on your desk right there. What's not on your desk is this quotient identities. This is what we need to do for transformations. You need to use these four, these four here and these two. These total 6 to transform everything to sines and cosines. So that's what I'm going to do here. Okay, so first, I'm going to rewrite a problem so we can look at the formula chart. Problem says we're trying to simplify tangent times cotangent divided by cosecant. All right, I want you all to look at these two sets of identities and tell me what tangent is equal to in terms of sines and cosines. So looking up at these 6 right here, what is tangent equal to in terms of sines and cosines? Yeah, so don't say 1 over cotangent because that's not a sine or cosine. What I want you to say is sine over cosine. And specifically, since this tangent's in the numerator, it's the same thing as tangent over 1 here. So how I'm going to rewrite this is I'm going to say this is equal to sine divided by cosine. That's the tangent portion right here. This tangent we applied, that was called the quotient identity. That's the quotient identity. Okay, now let's move on. What is cotangent equal to in terms of sines and cosines? Very good. It's cosine over sine. Again, you could make this divided by 1. You could do this divided by 1, and it doesn't make any difference. So it is cosine divided by sine. So I'm going to come over here. And we're going to say cotangent is cosine divided by sine. Now that was also a quotient identity. Now there's one more here. There's cosecant in the denominator. We want to change this to a sine or a cosine. So tell me, what is cosecant in the denominator equal to in the numerator? So find cosecant in the denominator. There it is. Cosecant in the denominator is equal to sine in the numerator. So I can change this CSC here in the denominator and make it sine in the numerator. That is sine right there. That is what we would call a reciprocal identity. And so I now have this. So I go back to spot oil. I just completed the transform to sines and cosines. So you start back up and say, can I simplify anything? Are there any opposites I can cancel? Sine. There's a sine multiplying and a sine dividing. We can simplify those out. You can cancel those out. Okay, great. Anything else? This cosine's multiplying, this one's dividing. Those can cancel out. And so what are we left with? Sine. That's it. Just sine. That would be your answer. And that's the last step right there. When you cancel, that's called algebra. Those are the Alex names. Technically speaking, I know I did this as 2 steps. If you were on Alex, your homework doing this would take at least at minimum 3 steps. You could do the quotients together as 1 step, both those quotients together, but the reciprocal would have to be a separate step, and then the algebra a separate step. So you could get away with doing this as 1, 2, and 3 steps. All right. So now that's number 1. Let's try number 2 here. During a scouting exercise, Alex leaves camp and hikes 4 miles northwest. Okay, northwest. What quadrant is northwest? First, second, third, or fourth? Where would northwest be? Second. Okay, what I want you to do on your paper is draw me basically a second quadrant. Don't worry about the rest. It says here, Alex leaves camp. So I'll put camp at the origin and walks 4 miles southwest. So I'm going to do something like this. He then turns and hikes 8 miles due north. So I didn't write these on there. Let me add this: north, east, south, and west. So 4 miles northwest. Then he turns and hikes 8 miles due north. Does that mean like this, pointed at the north? Does that due north? What's it mean to go due north from this spot? Straight up from this spot. Okay, so we'll just say that's 8 right there. All right, so they gave us that information. It says Karina leaves camp and plans to hike on a direct path to Alex's new position. What angle from the positive x-axis should Karina hike to the nearest 10th of a degree? So idea is this: Karina wants to meet up with Alex, and she's just going to walk straight to him. We want to know what angle should Karina walk. So what? I'm going to ask an obvious question. What shape are we looking at here? Triangle. Okay, to solve any triangle, you have to have 3 pieces of information. Right now, we only have 2, but there was something else given to us in this problem that I did not write down. What's that piece of information that I did not write down? Something else that will really help us with our problem. Okay, that's going to be for the answer. The angle we're looking for is from the positive x-axis. That is what we're looking for right there. Which that helps us know what we're trying to solve for, but that there's something else in the problem that I did not write. I'll give you a hint. It has to do with this northwest. How does that northwest involve my triangle? How many degrees is it from the north to the west? There's, just north to west. How many degrees are there between north and west? 90. Hey, Gabriel Lewis, make sure y'all are focused on my stuff, please. There's 90 there. This is northwest. What's half of 90? 45. Okay, so here's what I'm going to do first. I'm going to draw this on here and say that is 45 degrees. Now, here's the deal. That doesn't actually solve my triangle because that 45 is more than the triangle itself. It goes outside the triangle. But if I use a rule of geometry, we can actually say quite confidently that if I extended this line downward, using geometry's rule of you have a parallel line with a transversal, you can say these would be alternate interior. If this is 45 on this side of this line, you could say this is 45 right here. And again, that's not inside the triangle, but now I can get an angle inside the triangle. How could I figure out what this value is right there?
180 minus 45.
You got it. If we took 180 degrees and subtracted 45, we have discovered what this angle is right there. What is 180 minus 45? 135. We're going to say that's 135 degrees. Okay, so now I have three pieces of information on this triangle. I have a side length, a second side length, and 135. Would this be law of sines or law of cosines? Okay, that means I have a set. What's my set? 8 with 45. Problem, that 45 is not actually in the triangle. It's the triangle and some extra. It's going to be law of cosines. We do not have a completed set. So law of cosines. We could use this formula chart right here. There the three formulas are for law of cosines. I'll just take this first one. The law of cosines is that a squared equals b squared plus c squared minus 2bc times the cosine of angle A. All right, so I'm going to call this A. Since that's a camp there, I'll say that's C, which makes this be angle B. Okay, so if I want to plug this in, lowercase a is the side length. We don't know that side length yet. That's here. Hey, Mark. We don't know what A is. So algebraically, if I want to solve, what this formula will solve first for is this lowercase a. How would I isolate this A? Square root. Now, normally in math, if you're adding a square root that's not originally there, you need to add a plus or minus. Since this is a positive distance, though, I know it's got to be positive. So A will equal the square root of, now what's going to be lowercase b? If this is capital B, what is lowercase b? 4. So we'll say that's 4 squared plus, what's my, if this is capital C here, what side length is lowercase c? 8. Minus 2 times that 4 times 8 times the cosine of 135 degrees. Type that in the calculator and see what we come up with. So A would equal the square root 4 squared plus, 8 squared minus 2 times 4 times 8 times the cosine of 135. Now, there's going to be likely a mistake on mine or yours. You need to check the mode. What mode should we be in? Degrees. I'll check. Oh, I'm still in degrees from last class. So yeah, degrees. So the answer, I'm just going to say 11.19. We usually round to the nearest tenth. Let's say it's 11.1 or 0.2. 11.2. Let's say this is 11.2 now. So we just discovered this value is 11.2. Now, I wish that was the answer. It's not. It actually asks what's the angle to the nearest x-axis. Now, that's very important that we get this, but that's not actually even the answer. So let's think for a second. How could I get my angle from here? Let's think of the things we know. How many degrees are between north and east? 90. That's a 90 right there. And we know that 45 more gets us to the red line, but we want to know the distance to the degrees to the blue line. How could I figure out how many degrees it is from here, the east, to the blue line? Well, if we added, it would give me to the northwest, which is 135 degrees. So that's not it. How do I get it to the blue line? Any ideas? We'll use law of sines. Here's what we know right now. It's 135 to the red line. We need to take away however much is between the red and the blue. We take this amount away, we can get how many it is to the blue line. So that's what I'm going to do now. I'm going to erase this 45. We're going to find out how many degrees are right here. And we'll use law of sines for this. So the law of sines says if you take any completed set, which we now have, I'm going to take sine of angle A, which is 135 degrees. And we're going to divide that by 11.2. This will be equal to, I'm trying to solve this angle right here, angle C. So it'll be sine C divided by, in degrees, divided by 8. Now using some shortcut here with cross multiply, for the numerator, will I put it as 8 sine 35 on top, or will I put the 11.2 on top? That's right. This goes on the numerator, that you cross multiply that first. So we'll have 8 sine of 135 degrees divided by 11.2. Now here's the problem. That's going to equal sine C. How do you actually get rid of the sine? Y'all remember? How do you get rid of a sine? You can't divide it. What's the opposite of a sine? It's not a cosine. It's an inverse. What we're gonna have to do here is do the inverse of this. So we're gonna do sine inverse. It switches them, if you remember. That's what we're gonna do, and that'll come up with our answer here. So I'm gonna type in sine inverse, inverse of 8 sine 135 divided by 11.2. So I'm getting basically 30.3 or 30.4. 30.3, great. That's 30.3. We just discovered is C is approximately 30.3 degrees. So if this is 30.3, now we can solve for how many degrees it is to the blue line, because now we know from the east to the red line, we already figured that out. That's 135 degrees. So now we're trying to figure out how many degrees is it from the east to the blue. All we have to do is say 135 minus 135 minus that 30.3. What do you get when you do that? I'll let you type that into the calculator for your final answer. All right, once you get your answer, let's start on some new stuff now. So I'm going to continue on here. Let's look at example 1. So today, what's different from what we've been doing? Well, in the previous days, we were simply put trying to simplify equations without solving anything. On lesson 5.3, all of a sudden we start solving. We find out life is a whole lot better. What's going to happen today is the algebra you've learned in Algebra 1, Algebra 2 is going to meet trigonometry. And really how it's going to work is you're going to have a bunch of algebra steps followed by one trigonometric step. That's kind of the order. So let me explain here. Instead of trying to think through right off the top, how would I solve 5 cosine x equals 3 cosine x plus square root 3? I want you to think about this. How would you solve if it said 5x equals 3x plus square root 3, meaning there was no cosine whatsoever? How would you solve this problem? What would you do first? Okay, I hear simplify, which is the spot oil first step. How could you simplify this? 5x and 3x, those are like terms. You learn in algebra 1 to combine your like terms. How do I combine these? What is this 3x doing to the square root of 3 right now? It's being added. What's the opposite of being added? Subtract, because in algebra, you should have learned to solve any equation, you do opposites. So the opposite operation is to subtract 3x. What is 5x minus 3x? Is that 2? Oh, it is 2x. Okay, so it's not just 2. The x's don't cancel. It's just 2x equals square root 3. Okay, and then what would you do next? Again, you're trying to isolate. So what's the opposite of multiplying by 2? You would divide by 2. And thus, if you were in Algebra 1, you'd have your answer. You'd say, oh, x equals the square root of 3 divided by 2, right? Okay, so that's the algebra. What I'm saying is we're going to do algebra, and then at the very end, apply trig. So let me show you. I'm going to do the same steps. Instead of subtracting 3x, what am I going to subtract over here? 3 cosine x from both sides. First, subtract 3 cosines. So I have 5 cosines minus 3 cosines. That leaves me with 2 cosines equaling the square root of 3. Again, we're trying to isolate this cosine x. What's the opposite of multiplication? Division. So you would divide by 2. And so you have cosine x equals square root of 3 divided by 2. That, and all that was just the normal algebra. So what will we do from here using trigonometry is this. You'd ask yourself, on your cheat sheet, let me pull that up. On this cheat sheet, what is cosine's ratio? Yeah, x over h right there. I don't know what happened to that, but it's x divided by h. So I'm going to change this to x divided by h equals the square root of 3 over 2. Now, today, nearly every problem is going to have 2 answers. So we're going to look for 2 separate values. X is positive here, which means if x is positive, will on this unit circle, would it be up, down, left, or right if x is positive? Oh, that's wise. It's going to be on the right. We're going to look for the x divided by h, which is the x value before the comma, being the square root of 3 over 2. So let's see. We're looking only in the x column. Where do you see that? Is it there? No. Is it there? No. There? Here? Yes. Okay. We're going to use answers in radians, except for real world problems today. So I'm going to go radians all day. We have this value. At pi over 6, we have an answer of 3 pi, a square root of 3 over 2. So pi over 3 is going to be one answer. Not pi over 3, I'm sorry. Pi over 6. And I think there's going to be another one. There it is. They will almost always have the same denominator. Notice those 2 are connected there. So there it is. The other answer is 11 pi over 6. Something here a little weird. If you remember your lesson 4.4.4.5 with graphing, if there's no limits on domains, because these are periodic functions that repeat, there's an infinite number of solutions. So what you're going to do to represent the infinite number or all the coterminal solutions is you would say plus 2n pi. That just means plus all the coterminals. So these 2 answers plus all the coterminals. This is anytime n is an integer, this works. That this double z means integer. So that is my value there. Let me put that note where n is an integer. Where n is an integer. That's fine, right there. Okay, so and let me put that on the note. Here, this just means plus all of the coterminals. That's all that means there. All right, with that, I want you to try what I'll call first basic algebra, followed by trigonometry in the last step. Okay, I want you to do this on DOL number 1. I want you to try this one, DOL number 1. Remember to combine your like terms first. Combine like terms, isolate, and once you isolate, convert to trigonometry and solve. All right, so now let's look at example 2. So again, I'm just going to pick up difficulty of algebra as we go, but here I would still call this algebra 1. Looking at this problem, just pretend for a moment it said 3x squared minus 4 equaled -3. What would you do first if that were the case? We would add 4. We combine our like terms. And that's exactly what we're going to do here. So now I have on this right side, the algebra model, 3x squared equals 1. Truthfully, in the problem, we have 3 tangent squared equals 1. Okay, so what would you do next using this algebra model? Oops. We would divide by 3. And that's what we're going to do here on both sides. We're going to divide by 3. So basically what I'm trying to show you is when you do algebra with trigonometry, you don't do it any different than anything you've learned before. And so we now have tangent squared x equals 1/3, or you could think of it as x squared equaling 1/3. All right, how would you solve that? What is the opposite of a square? Square root. Now in math, anytime you had a square root that's not originally there, what does it need with it? Plus or minus. The only time it doesn't is if you know the answer is supposed to be positive or supposed to be negative. This one we don't know. Doesn't tell us anything about that. So we're going to add plus or minus. And at this stage, I'm going to just start skipping now. According to your cheat sheet, what is tangent's ratio? Not x over y, y over x. Okay, so tangent is y over x. I'm going to rewrite this saying that y divided by x equals plus or minus, and I'll reduce the square root. What is the square root of the numerator? Square root of 1 is, what's the square root of 1? 1. And what's the square root of 3? We don't have one, so it's going to look like that. Okay, so this is the values we're going to look for. This says it could be positive or negative. So this one, we're not going to have just 2 answers. We're actually going to have 4 answers, 2 positives and 2 negatives. So let's go over to our unit circle. And we're going to look for the y needs to be a 1 and the x needs to be square root of 3. Okay, so as we look around our unit circle, we're looking for a y value of 1, x is square root of 3. So as I go through, I need a y value 1, x square root of 3. I see 1 here.
There's 4.
There's 4. Where are the other ones?
On the second quadrant.
So we're looking second quadrant. Where?
Maybe for 3.
Okay, help me out, Maria. Where do you see 1 in the second quadrant? Yeah, with a 1 and a square root of 3. It doesn't matter if they're positive or negative. 150 degrees, same thing as 5 pi over 6. We have 1. There's 1. Okay, in the third quadrant, where's our answer in the third quadrant? Adrina, where do you say? Hey, Mark, focus with me, please. Where's my answer in this one?
It would be 11 pi.
11 pi over 6 would work. That's fourth quadrant. We got 1 more in the third quadrant. Where is it?
7 pi over 6.
7 pi over 6 also works. Again, positives and negatives don't matter on this one. So there's looks like 4 answers. Now here's a shortcut if you have 4 answers, especially when they're all the same denominator. If it's 4 answers, all same denominator, you do not have to do plus or minus 2 pi. Here's how you would write your answers. You just write the first 2 that occur, which happen to be pi over 6. Whoops. Instead of writing all 4, what you're going to do is write pi over 6 plus, instead of 2n pi, you're going to write plus n pi. So instead of saying all the way around the circle, it's just half a circle. That will get the first answer and the third quadrant answer. And then you list the second quadrant as well. 5 pi over 6. But notice I'm only going to do plus n pi this time. That will get all 4 answers right there, where n is still an integer. So now this is going to include first quadrant and third quadrant answers. So that right there is first and third quadrant answers. Solutions or coterminals, you could say. Where down here, the last one would be second and fourth quadrant. These would be the second and fourth quadrant. Coterminals. So that's all it is when it has just an n pi. That's what it means. All right, I'm going to give you a few moments to work on this problem here. DOL number 2. Use your algebra, solve here. Okay, let's take a look at example 3. Now here's where we start moving into what I would call algebra 2. So we're still doing the same process. Algebra first, trigonometry to finalize our solutions. This time I have this problem here, and some students might say, hey, I know what we could do. We could divide sine from both sides. Here's the problem. You're not allowed to divide by anything that has a variable in it. So if you think you can do this, this is wrong. What I'm writing right now is wrong. If you thought you could do this, well, I understand why you think that, but you're not allowed to divide by a variable. Do you know why you're not allowed to divide by a variable? Wow, can't talk. Do you know why you cannot divide by a variable? There's a rule in mathematics about division, something you're not allowed to divide by. You're not allowed to divide by 0. Do we know whether or not sine x is 0 or not? We don't know. So you're not allowed to divide by it if it could possibly be 0. So I can't do it that way. So what do I have to do? I'm going to have to do what's called a GCF. I'm going to have to factor. So here's what we do with factoring. In Algebra 2, what you learn is you get all the variables to one side of the equation. So what I'm going to do first here is subtract the square root of 3. Basically, what I'm doing right now, just to simplify the problem for you in your head for a moment, it's kind of like saying this. Since there's a 2 sine x cos x, it's kind of like 2xy equals square root 3 of x. That's basically what we're looking at right here. And so what we're first doing, or we're getting the variables to all the one side of the equation. This does simplify out. Over here, these are not like terms, so I cannot combine them. So it's going to be 2 sine x cos x minus the square root of 3 sine x. All that would equal 0. Now in Algebra 2, what you start learning is that if you need to solve with multiple variables, they're not like terms, you factor. The easiest type of factoring is called GCF. GCF is the opposite of distribution. You look at the first term and the second term, or any extra terms if it has more than 2, and you ask yourself, what is common in both terms? Sine x. So it's the opposite of distribution in the sense that we're going to divide out the sine x. The sine x will get divided out, and so the sine x comes outside of the parenthesis, and what remains in the parenthesis is what's left over after removing the sine x. So in the first term, if I divided out this sine x, what's left over? 2 cosine. And on the second term, if you divide out the sine x, what's left over? Square root 3. Now, the reason we factor in Algebra 2 is you learn, if I could summarize how is Algebra 2 different than Algebra 1, I would summarize in these words: the zero product property. This is what Algebra 2 is all about, is learning how the zero product property works. And it's this: if you have a product, which we do here, sine x is multiplying with this parentheses. If you have a product and that product happens to be 0, you know one of the factors must be 0. There's only one way in math, only one way to multiply and get a product of 0, and that is to be multiplying by 0. So at this stage, since they're factors, you set up each factor as being equal to 0. So I'm going to say sine x equals 0, and I'm going to say 2 cosine x minus square root 3 equals 0. Again, remember why I said I could not divide by sine earlier? It's because there's a potential that sine could be 0. Yep, there it is right there. Now this one is already set up for us to solve. This is great. After you do zero product property, you should be Algebra 1 from here. Sine is what ratio? Look on your cheat sheet. Sine is y divided by h. Okay, so we're going to have y divided by h. Y divided by h equals 0. So let's go over here and look for that one. We want to know where the y value is 0. Where do y'all see those spots? I hear 90 degrees. That's x though. Yeah, and I'm going to go off radians. So we have it here and at pi. Those two spots. This says on the interval, that means x values. Interval means x values. 0 to 2 pi with a bracket on the 0. What does it mean to be a bracket? You include 0. What does a parenthesis mean? Do you include it or not include it? Don't include it. So we boxed up 3 values, 0, pi, and 2 pi, but I'm not going to include 2 pi.
No.
So the only two are 0 and pi. Okay, so we just came up with this solution being 0 and pi. Those are those two solutions. Now let's come over here and let's solve this. What would be our first step to solve from here? Add square root of 3. And second step?
And then divide by 2.
Divide by 2, good. And so now we're looking at cosine x equaling square root of 3 divided by 2. What is cosine's ratio? I agree with you. Cosine's ratio is x divided by h. So we're looking for x divided by h. X divided by h to be equaling square root of 3 divided by 2. So find those two spots. Pi over what? Pi over 6. Do y'all agree or disagree with pi over 6? I agree. Okay, there's one more. 11 pi over 6. Yep. And this one, on my answers here, when I write these out, you would not have to, let's just put this over here. So we had pi over 6 and 11 pi over 6. You would not have to do the plus 2 in pi or anything like that. The reason being is they only want these answers. They don't want any coterminals. So another way is saying here, no coterminals on this. No coterminals. That's what that's saying when they want it on that interval. So since I don't want any coterminals, I just say here's my answers. My answers are 0, pi, pi over 6, and 11 pi divided by 6. Those would be my solutions right there. All right, let's check out 3B. So there wasn't the only type of factoring, wasn't GCF that you learned in Algebra 2. You also learned other methods, and in my class as well. First day of school, we dealt with this exclusively. What would you do if you came across something that looked like this in my class at the beginning of the school year? 2x squared plus 1x minus 1 equals 0. How would you solve that? It wasn't add 1. There's multiple variables that do not combine. You don't just isolate it. There's a different technique. X method. You would say, hey, this is my A, this is my B, this is my C. And we would do X method. Factors of A times C that add up to B. And you would go from there. Do you remember that? Same concept here, but we're going to use these terms. So here's my A, here's my B, here's my C. B does not have a value. So what are we going to say? What number should be there with the sign? How many signs do I have? 1. So here's what we do. We draw our x-axis or our x method. What is 2 times negative 1? Negative 2. And then B is 1. Goes down here. Now we're going to look for 2 numbers, which we called M and N at the beginning of the year. 2 numbers that multiply to be the numerator, divide to be, excuse me, combine, add or subtract to be the denominator. So I'm looking for 2 numbers that add to be, multiply to be negative 2, add to be 1. Sorry, that's tongue-tied all day today. So what are the only factors of 2? 1 and 2. That's the only one. It has to be those. How do you make them turn into being a positive 1? Okay, 2 minus 1, y'all are saying? 2 minus 1, I agree with that. 2 minus 1 would work. So 2 minus 1. All right. Now what we did, that was the, when we did GCF, or excuse me, when we did X method at the beginning of the year, I said, hey, first step, do your X method here. The second thing we did is we came over and you split the A term's power. You split this power. So in parentheses, we would have 2 sine X. So you split the power in half, so it becomes a power 1. And then you put in the side to the of your X. So it'd be 2 sine X plus 2. And then I'd have another 2 sine X minus 1. Now you might remember this. The reason we split the power is because if you multiplied these out, that would be the sine squared, sine times sine. However, if I multiply those out, 2 times 2 would be 4, which is supposed to be a 2. So we had a step that only happens or only occurs when A is greater than 1, which it is here. And that is you have to do bottoms up. Which term has this factor of 2 being shared in the parenthesis? The front term or the front factor or the back factor? Back. So this one would get divided by 2. So mathematically, to have an accurate statement, you'd actually have this: sine x plus 1 times 2 sine x minus 1 equals 0. That's actually how this problem right here factors. So now I can do the zero product property. The reason, this is all algebra 2 right here. If you have terms of x that do not combine together, so you have more than one x value that do not combine together, you have to set them up as factors equal to 0, so you can do the zero, I forgot the word product, zero product property, zero product property. So that's where I'm at now. So we'll say that sine x plus 1 equals 0, and we'll say that 2 sine x minus 1 equals 0. Okay, I'll solve the left first. How would you, what's the opposite of adding 1? Subtract 1. So we have sine x equals -1, and sine is y over h. So we're actually going to have y over h equals -1. So where do you see y over h equaling -1? Y over h equaling -1. -1 over 1, I should say. -1 over 1. Alexis says 3 pi over 2. Y'all agree or disagree? This is a weird one. This is the only one, I say the only one. There's only a couple values on here that you can only have one answer. This is one of those times. The only way to get a value, a y over x that's equaling y over h, I'm sorry, y over h that equals -1 over 1 is to have it at 3 pi over 2. It's the only possibility for that. So there's one solution. Okay, now let's go solve this other zero product property. What would I do first on this side? We would add 1. So here, then we'll divide by 2. Let's check it. Does it look like I should divide by 2? Yeah, I think so. We divide by 2. So we're going to look for y over h equaling 1/2. So now we're looking for y over h because it's still sine. I don't know why I circled tangent earlier. That was a mistake. We were getting y over h both times. I should have had that circled. Okay, so we're looking for 1/2. Did y'all already say it?
Pi over 6.
Pi over 6. I agree with that one. And 5 pi over 6. I agree with that as well. Those are my values right there. So pi over 6 and 5 pi over 6. So those would be my 3 answers. If you wanted to go in order, it would be pi over 6 first, then 5 pi over 6, then 3 pi over 2. That's in order of the unit circle. That right there, those solutions. Yep. All right, with all that, hey, can I show you something? Yeah, sure. I'm going to open up Desmos. We've been doing a lot of algebra today, right? Have I told you how to insolve so far this school year? I have. I taught you if you want to insolve, you just type in y equals the left side of the equation and y equals the right side, meaning where the equal sign is, you divide it. If you were to do any of these problems I've worked through today, any one of them, you could actually get your solutions just by, some of y'all are like, really, you waited till now to tell us? Yes, I did. If you did y equals the left side and then y equals the right side, just like I've done here, I'm going to switch back to radians because that's the answers I've been working with, pies. If you graph these and look for any answer that occurs between 0 and 2 pi, which if you want to know how to restrict the graph, you can use these little squigglies like this. I can do 0 is less than or equal to x, which is less than 2 pi. I want to paste this on both of them. And notice I did not do the equals on 2 pi because it's a parenthesis. This would limit my graph, and you would find any intersection in that window right in here. And so how many solutions do you see? I see only those 3 solutions right there. Pi over 6, 5 pi over 6, 3 pi over 2. Is that what we got? So all this work we've been doing, you can actually just use your calculator and solve if you wish.
For one circle.
What's up?
What does the 2 pi do restricted to?
Yeah, that restricts it to one circle where you do not include 2 pi. That's correct. If it said to 4 pi, it'd be the circle plus the second circle.
All right.
You got it. All right, your turn. DOL number 3. You can use whatever technique you want, whether you want to use algebra or graphing technique. All right, so now what we're going to do is I'm going to transition. There is identity in here I have not taught yet. So on this one, I am going to use the calculator on this problem here. So I'm going to walk you through it. It says this: a projectile is sent off with an initial speed of, and it says v0. You physics students, when you see v0, what is that telling you about the velocity? Initial. If you ever see that 0, it means it's the initial. So the initial is 350. And it clears a fence 3,000 meters away. Okay, question for you. If it says it clears a fence 3,000 meters away, does it mean it's 3,000 meters tall? Or like the x value, the x distance is 3,000. What is that telling you? The x distance. So this is like an x distance, which is going to come in handy in a second. It says the height of the fence is the same height as the initial height of the projectile. If the distance the projectile traveled is given by this formula, find the interval of possible launch angles to clear the fence. So as we plug in stuff, where do you think the 350 will go? Where's the 3v0, the initial velocity? Okay, where do you think the 3,000 will go? D, very good. This is going to be D. Now, there is a formula on the formula chart for this. You could look at it. If you wanted to do this on your own, you could come over here and it's right here. You can use this formula, but I'm not going to use that. What I'm going to use instead is the calculator here. So I'm going to come back, and what we're going to say is I'm going to put this as y equals 3,000 and y equals 350 squared sine, what I'm going to do is 2x divided by 9.8. Y'all know what 9.8 is? Gravity, 9.8 meters per second squared. So let's go to our calculators, and I'm going to graph these now. Y equals 3,000 and y equals 350 squared sine 2x divided by 9.8. Now, this problem is different. Is this problem in radians or degrees? It's real world. So what I want you to think about is radians sounds like the word radius. And if you remember, a radius is on a circle. A radian is a measure of radiuses along a circle. This is real world. In real world, you don't use circles to measure things. You use degrees. So I want you now to switch your mode to degrees. We should be seeing 2 graphs. I only see 1. That's because y equals 3,000 is so high. I want to know my angle, and the y value needs to go as high. I'm just going to do the settings right here. It needs to go at least to 3,000. I'm going to put in 4,000. And since I'm dealing with angles, I'm going to look between 0 and I'm going to put our -1 and 185 degrees. I'm going to look for my angle somewhere in there. So I just changed my x-axis to extend to 185, and my y, because again, real world with angles, we usually just go up to 180, and my y's up to 4,000. When I look at this, I see my answer. Whoa, I see multiple answers. Okay, we want to know what angle produces a projectile that clears that distance. So it's going to be in here. Now remember, with real worlds, you do not count values that are negative, so you don't take anything outside the first quadrant. So truthfully, I should only be looking at values that have positive x's, and I don't want anything that goes beyond where the y when it's below 3,000. So I'm only looking in this area. The angle would have to be between these two spots. It's between these two spots that my true solution would be. The other ones, they go outside the first quadrant, so I would not include those. I'm looking at anything, what does it say to round to? I'm just going to go to the nearest degree.
It doesn't say.
Yeah, it doesn't say. How many degrees is this if you round it?
6.5.
Let's just say 7 degrees, anything between 7 and 83. And so the way the answer would look is you would say the answer is somewhere between 7 degrees and 83 degrees. As long as you launch somewhere between this angle, you should get your solution. So that's what I did here to be able to see the graph and come up with the correct solution. Honestly, this x value went way too far. I don't need to see beyond 185. So I could have listed it like that, and you see there the proper graph. Okay, now with that, I'll let you try your DOL. You duplicate the same thing, see what you come up with. All right, example 5, find all solutions of sine squared x minus sine x plus 1 equals cosine squared. All right, what's tricky here? Hey, stick with me, please. If you were trying to solve this one is you cannot factor right now because I cannot set it equal to 0. So what you have to be prepared to do is other trig identities. In this case, on example 5, what I would have is a Pythagorean. I'm going to talk about cosine squared here. And on the formula chart, what we can say about cosine squared, let me clear this and zoom in, is that cosine squared on Pythagorean, cosine squared would be equal to 1 minus sine squared. Cosine squared would be equal to 1 minus sine squared. You can see that would cancel out. And so what I'm going to do here first is substitute using Pythagorean. Is I'm going to change that and say we have sine squared x minus sine x plus 1 equals 1 minus sine squared x. And that was using the Pythagorean right there. That right there was Pythagorean. And now I can combine my like terms. I can subtract 1 from both sides, and I could add a sine squared to both sides. So I should have 2 sine squared x minus sine x equals 0. Now as I go through my simplifying, I can say, oh, with confidence, I have a GCF. What is common in both these two terms? A sine x. They both have a sine x, both in the front term and the back term. So what I'm going to do is factor out 1 sine x. So what does that leave me with? When I do a GCF, I'm left over here with just a regular sine, 2 sine x minus, and here there's just one of them, so I'm left with 1. And now I can do the zero product property. And so I'll say that sine x equals 0 and 2 sine x minus 1 equals 0. Sine x is y divided by h. And over here, I would need to add the 1 and then divide by 2. All right, so now let's go, look at where these values are found. So we're looking for, what happened to me here? All right, we're looking for the y over h to be 0 over 1. So the y over h to be 0/1. So I'm looking in the y column and I see 1 here. And so we'll have, since the answer is supposed to be between 0 and 2 pi, but not including 2 pi, well, I'm just going to take the 0 there. Oops. And we will also have, as I look around, I see another one right here. We'll take pi as an answer. So this one generates 2 answers. Y over h being 0/1, that is 0 and pi. We won't include the 2 pi because 2 pi is in the parenthesis there. And now I'm looking for y over h to be 1/2. So I'm looking y over h to be 1/2. Here's one right here at pi over 6. And I have another one over here at 5 pi over 6. So we're going to use these 4 answers here. So pi over 6, 5 pi over 6. This is pi over 6 and 5 pi over 6. Okay, so checking it graphically, let's now make sure we got this correct. I'm going to do y equals the left side, y equals the right, and just to make sure these are correct. So we have y equals sine squared x minus sine x plus 1. And I also had y equals, was it cosine squared? Yes, cosine squared x. I won't put the restriction, so I'm only looking at the graph from 0 to 2 pi. So I'm going to extend this out so you can see what I typed in. And I'm going to do that also for this red graph. And so when I look at this, I'm going to look where these two intersect one another. Go back to radians. And here we should see, we had on our algebra, we had 4 answers. So I have 1 there, 2. This is not an answer because it's not an intersection. 3 and 4. Looks like 4 intersections, 0, pi over 6, 5 pi over 6, and pi. We would not include the 2 pi because that was outside, was parent, let's go with a parenthesis, so we wouldn't include 2 pi. So it would be these 4 answers, 0, pi over 6, 5 pi over 6, and pi. Those would be our answers. So I'm going to copy this over. Now you can try dual number 5. All right, let's look at example 6. So find all solutions here. Sine minus cosine equals 1 on the interval 0 to 2 pi. Again, we could just use a graphing technique, but what I'm going to use is our spot oil just to show you the algebra. Now, what's tricky here is I have, again, a sine and a cosine, and they're not squared. What I'm going to try to do is turn these both into the same value functions. And so the way to do that, what I'm going to do, meaning the same, like, let's get them both to sine. What I have right now is so my method of getting this solved is what I'm going to do is I'm going to add a cosine to both sides. And I'll show you why I'm doing this in a moment. So when I add this cosine to both sides, what I now have is sine x equals 1 plus cosine x. And the reason I'm doing this is I want to get all to the same trig function. And so I know a connection between sine and cosine is a Pythagorean. And so what I'm going to do is square both sides of this equation. Let me actually show you the Pythagorean so you know what I'm talking about. Let me go here and zoom in on this. The Pythagorean, what I'm basically going to be doing, well, it's kind of like this one, except just as a minor change. Let me delete this. What I'm going to do is get sine squared by itself here, which means I'm subtracting cosine squared from both sides. This is the idea of what I'm actually going to use here in a second, is this identity right there. And so when I square both sides, I now have sine squared equals, and I need to FOIL this out. So it'd be first times first. So 1 times 1 is 1. Then it'd be first times the outside. So 1 times cosine would be a cosine x. And then it would be the inside times inside. So it'd be a cosine times a 1 that would be right here. So we'd have another cosine. Actually, let me just write it this way. Instead of squaring it, so you can see it. So 1 times 1, 1 times this cosine times 1 is right here. And now cosine times cosine is cosine squared. So I just FOILed that out. That's what I did there. I FOILed And so now I have this set up. Well, I can use the Pythagorean to say sine squared, but I just wrote over here, sine squared is equal to 1 minus cosine squared. So this is 1 minus, whoops, 1 minus cosine squared x. That's using Pythagorean. And that would equal 1 plus, well, you know what? There's 2 cosines here. So cosine plus cosine is just 2 cosines plus cosine squared x. Now what I'm going to do is I'm going to combine like terms. So I see both sides have a 1, so I can subtract that. And both sides have a cosine squared, so I can combine those. So the left side is going to become just a 0. 1 minus 1, that's 0. And I will reorder this. I'm going to put the 2 cosine squared first. There's 2 of them. 1 plus 1 is 2 cosine squareds. And then I have 2 cos x. To solve this, what I will do is I will divide by 2. When you divide, it works like the multiplication. You distribute. So everything gets divided by 2. 0 divided by 2 is still 0. But now I'm left with cosine squared x plus cosine x equals 0. And finally, last step, what I'm going to do here is now factor. I have it set equal to 0, but I have cosine that's squared and a cosine that's not. So I'll factor to solve this. I'll do a GCF here, a GCF. And so we'd have 0 equals, I can pull out a cosine. They both share 1 cosine. So I can pull that out front. Cosine x times, when I pull out 1 cosine from here, I'm left with 1 over. And when I pull this out from here, I'm left with just 1 cosine. I had 1 cosine. When I pull out the cosine, I'm left with just 1. Like that. So now using 0 product property, we could solve this. 0 product property. So I would be solving that cosine x equals 0 and that cosine plus 1 equals 0. Cosine, let me go over here. Our cosine is x divided by h, which is the wrong one. Let me try this one. And so since I'm dealing with cosine, I'm looking at x divided by h. And so we need x over h to equal 0 divided by 1. And over here, when I subtract the 1, it would be x divided by h equals -1 divided by 1. So those are the spots I'm looking for. X comes in the front column. I'm looking for x divided by h, the front column. So I'm looking for a 0 divided by 1, which is there. And here at 3 pi over 2. So pi over 2 and 3 pi over 2. And I was also looking for -1 divided by 1. So the only x that I have that's a -1 divided by 1 comes here at pi. So it looks like I have 3 answers here. It looks like we have the answers from this spot right here. Let me get a little white space to write on. It appears that we have 3 answers. It appears that we have from 0 over 1, pi over 2, and 3 pi over 2. And from -1, we'd have the answer pi. So we think we'd have 3 answers. I say we think because sometimes when you do the trick I just did, when you square, you create an answer that's not truly there. So what I'm going to do is graph this. So we did all this work, and the whole time, like I said at the start, you could just graph this and solve by graphing. So here I've graphed the left side of the equation, and now I need to graph the right side. And we look for intersections. You'll see there's only 2, pi over 2 and pi, which means this is an extraneous answer here. Extraneous just means it's extra, it's not a real answer. Mathematically, it seemed like it was going to work, but it was actually not a real answer the whole time. So that's extraneous. That means this is a good answer, and this is a good answer. We only have 2 good answers. So with that, I'll let you do DOL number 6, but I would recommend you graph this, solve by graphing as opposed to doing the algebra. It's my recommendation for you. All right, spiral review. Let's finish this ACP question here. It says 2 siblings are flying a kite. The brother and sister are 100 feet apart, shown here, from one another. The older boy to the kite, there's an angle of elevation of 45 degrees. From the younger sister to the kite, there's an angle of elevation of 50 degrees. What is the height of the kite rounded to the nearest foot? So ultimately, what we're going to be looking for is this height here. We're trying to figure out how tall is this. So how could we find out how tall this is? Could I just say that's 50, that's 50? It's an accurate statement to say it's 50 on both sides. This cuts it right in the middle. No, it's not. You know why it's not? Because these angles are not congruent. If the angles were congruent, that would be true. They're not. Hey, Gabriel. So I have to, before I find the height, I have to solve this triangle a different way. So how can I solve this triangle first? Do we know, we have two angles. Can I find the third angle? How many degrees are in every triangle? 180. So we could say 180 minus 45 minus 50. Anybody know what that is off the top of their head?
75.
Here's 75. That's close. 85. There we go. It's 85. Okay, so now that I have all three angles, which law will we use here? Law of sines or law of cosines?
Law of sine.
Law of sines. If you want to use law of sines, again, this is on the formula chart. What we're going to do is take sine of the completed set. What's my set? What's my completed set here? 85 over 100 feet. And you're going to set this equal to any other set. All right. So let's go, Anthony. I'll let you pick. Do you want to solve for this dashed line across from 45 or the kite string across from 50 degrees? Dashed line. Okay, we're going to solve for this one. I'll put an X there. So we're going to say sine 45 divided by X. Okay, Lewis, how do you solve this algebraically? Two fractions set equal to each other. All right, then make sure you're with me then if you're not sure. Okay, so class, how do you solve this? What's the shortcut? You cross multiply with the stuff without the X. So we'll say X will equal, it'll be 100 times sine 45. You have that cross multiplying, and then you divide by what's supposed to multiply with the X, which happens to be sine 85. Make sure you're in degree mode. Go type this in your calculator and let's see what we come up with. I want to make sure I'm in the right mode here. I'm in degrees. So the answer is approximately 71. I'm going to write down 70.98. 70.98. Yeah, we'll get there in a second. Is that actually my answer though? No, we need to find, that's why I don't want to round too soon. Make sure I don't have a mistake here. I don't want to have a rounding error. Now that I know that, I can now solve for the height because I can look at this now as two separate triangles. We can say, we can find the height because if I look at this as its own triangle, I now have a shared side. Remember the day we did this way back when the strategy was to find this shared side? Now I have a shared side to the triangle. Now I know that I can solve this problem. How many degrees would go right here? 90. So I can do another sine of 90 degrees over the 70.98 and say that'll equal, this height is across from 50. And we can get our solution this way. So I'll cross multiply again. You multiply the stuff on the top, or I mean the cross that does not include the H. So it'd be like 70.98 times sine of 50. And then here you divide by sine of 90. This part we do the dividing. Y'all remember the shortcut for what sine of 90 equals? 1. That's just dividing by 1. So something else in my calculator, since I typed this in as X already, I could just do X sine of 50. H equals X sine 50. And that should give me an answer. I won't. Maybe if I had to put an X1 there, I think. Now, will it? X1. Yeah, there's the height. And if you're not sure, you could just type in that 70.98 sine of 50. And you see, you do get the same answer. And so to the nearest foot, our answer would be 54 feet.